Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, this is lesson 23, Modeling with Quadratic Functions. Okay, this classwork opening, the mathematics of objects in motion. It says to read the following explanation of the mathematics of objects in motion. I am not going to sit here and read to you. Pause the video, read this, or read it from your module, and then continue to the next page. Okay, so page 2, we're now going to apply that equation that they explained on page 1. And it says these physics functions can be used to model many problems presented in the context of free-falling or projected objects, which are objects in motion without any inhibiting or propelling power source, such as a parachute or an engine. So mathematical modeling exercise 1 says to use the information in the opening to answer the following questions. Chris stands on the edge of a building at a height of 60 feet. Okay, so he's standing there at a height of 60 feet. Right there, and throws a ball upward. So this height is the initial altitude or height. Initial height is 60 feet. And the initial velocity is 68 feet per second. So that ball coming out of his hand is coming out at 68 feet per second. The ball eventually falls all the way to the ground. What is the maximum height the ball reaches? How many seconds will the ball reach its maximum height? And how long will it take the ball to reach the ground? So A says, what is the units, or what units will we be using to solve this problem? So the unit of measurement we're going to be using is feet for height, height of 60 feet, seconds for time, right there, initial velocity is 68 feet per second, and feet per second for the velocity. So we're using seconds for time and height and feet per second. B says, what information from the contextual description do we need to use in the function equation? Okay, well, we need to know that gravity equals negative 32 feet per second squared. And we need to know that the initial velocity, v sub 0, is 68 feet per second, which is right here in green. And we also need to know the initial height, which is h sub 0 of 60 feet. And then so finally we have this equation. And the equation is negative 16t squared plus 68t plus 60. So the 68 feet is here. Velocity is your linear term. Height is your constant, where we start. And you remember the equations, the function said to take half of 32. It was 1/2 of the gravity's pull, which is negative 16 is half of 32. So now C says, what is the maximum point reached by the ball? So what we're really doing here is we are graphing a quadratic, okay, t squared. So it is a parabola, and A is negative, so it looks like this. So here's the building. He's throwing the ball off the building. So this here is 60 feet, just to draw a picture of what this looks like. So he's throwing the ball from up here, 60 feet, a velocity of 68 feet per second. The ball comes up, it finally starts to lose momentum and stop, actually, and then turn and start to fall to the ground. So it goes all the way down and kerplunk on the ground, and we want to know how long it took. But first we want to know what the maximum point of the ball is, which is right here. Well, the maximum point is the vertex. So we could complete the square here, but half of 68 is, well, we would factor first, of course. So there's different ways we can do this. And there's an easier way than completing the square sometimes, because it gets pretty messy if I try to complete the square on this. I first have to group my variable terms, and they're going to be factorable by -4. So I pull out -4, leaving 4t squared plus 17t. Well, half of 17 squared, it gets to be a pretty big number. So we're going to do this a different way than completing the square. Okay, so let's do it this way. If I have h of t equals negative 16t squared plus 68t plus 60. Okay, I can factor out a 4. So if I take negative 4 out of this, then that 16 divided by 4 is 4t squared. Negative divided by negative is positive. 68 divided by 4, and it's positive divided by a negative, so it's minus. 4 goes into 6 once with a remainder of 2, and 4 goes into 28 7 times. And then finally, oops, not plus, positive divided by a negative is negative. 4 goes into 6 once with a remainder of 2. 4 goes into 25 times. So there is my factored form. I've factored out a negative 4. 17's prime, so there's no more factoring. So now I need to know what, I'm now going to find the 0. So I'm going to find this point here, and if this were to continue down to the ground over here, I'm going to find this value here. And the vertex is the midpoint between these two zeros. Okay? And once I find that midpoint, then I can plug that into my equation and find the y value, and that would be the height. So that's what we're doing. All right, so I've got a different way to do this. So what I do is I call it the Beats method, because it looks like those old Beats headphones. It's kind of outdated now because everybody now wears the earbuds, but here's what it looks like. Okay, so I just rewrote this over here, and I am going to take my first term, and this is why I call it the Beats method. It looks like headphones. All right, and I'm going to now rewrite this as t squared minus 17t minus 15 times 4, which is 60. So now I'm going to factor, and I'm going to find factors of c that add up to b. This is c. What factors of 60 add up to 17? Well, we have 1 times 60. That doesn't work. That'd be 61 or 59. 2 times 30. Well, that'd be 32 or 28, depending on the sign of these, right? And then 3 times 20, and there you go. There's a difference of 17. So I'm going to put a 3 here and a 20 here. And this has to be negative, so the bigger one's negative, the smaller one's positive. So when I FOIL this, negative 20 times 3 is negative 60, but negative 20t plus 3t is negative 17t, and t times t is t squared. Okay, but I multiplied by 4, so now I need to divide by 4. And when I divide by 4 and it's a fraction and I can't make it an integer, then that tells me to make that my coefficient. So now I have 4t plus 3, and then t minus 20 divided by 4 gives me an integer, and there is my factored form. Okay, hopefully that is not too confusing for you, but that's how I teach factoring where a is not 1. Okay, so now we know that this is going to be negative 4 times 4t plus 3 times t minus 5. All right, so now when I set these equal to 0, that'd be 4t plus 3 equals 0, and t minus 5 equals 0. And when I solve this, subtract 3 over here and divide by 4, I get t equals negative 3/4. And I get over here, I add 5 to both sides, and I get t equals 5. So there are my two zeros. Okay, so now we want to find the midpoint between 3/4 and negative 5. Well, remember that midpoint is the sum of the 2 points divided by 2. So 3/4 plus, and since I'm adding fractions, how about I make this a fraction? It'd be 20/4. 20 divided by 4 is 5, right? It's right, and so it's right here. So now I have this. Negative 3/4 plus 20/4 divided by 2. Well, that's going to equal 17 over 4 divided by 2 over 1, which is the same as 17 over 4 times a half, which equals 17/8. 17 over 8. Okay, so that is my t. Okay, that is when this is the midpoint right here. That is the t value, 17/8. So if I substitute this into this function, I will find the height at this time. Does that make sense? So I want to do h of 17 over 8 equals, and I'm using my original up here, negative 16 times 17 over 8 quantity squared plus 68 times that 17 over 8 plus 60. Okay, so to ease the pain, I'm going to use my calculator to do this. And I'm going to just put that in the calculator. Negative 16 parentheses 17 divided by 8. Close the parentheses, but I also need, no, I don't need another parentheses. So I need to square that. So negative 16 times 17 8 squared plus 68 times 17 divided by 8 plus 60. And I hit enter, and I get 132.25. All right? Okay, so h of 17 eighths equals 132.5 feet. Okay, so that is this value right there. So what is the maximum point reached by the ball? 132.5 feet. After how many seconds will it reach that height? 17 divided by 8. So if I want to put that in a decimal form, 17 divided by 8, 2.125 or 2 1/8. Okay? So after how many seconds? It would be t equals 17 eighths, which equals 2 1/8 seconds. Okay? And now it says, show your reasoning. Well, I just did. All right? You could also have used the vertex formula, but it's a little bit tricky completing the square with such numbers and factoring and all that fun stuff. So anyway, let's recap. So this guy's standing at the top of the building, 60 feet above the ground, throws the ball up at an initial velocity of 68 feet per second. The ball goes up, and when it reaches 2.125 seconds it took it to get from his hand to its maximum height of 132.5 feet. And then it turned and it fell and it went down to the ground and it landed at the ground at time 5 seconds. So the whole event from out of his hand to the maximum down to the ground 60 feet below him on the street level took 5 seconds. Pretty cool stuff. Okay, page 3 brings us to part D of the question, and it says, how long will it take the ball to land on the ground after being thrown? Well, I kind of summarized a little before, so let's go back. And so our two zeros, which would be here and here for my little sketch, were -3/4 and 5. Well, time being -3/4 does not make any sense. So that is an extraneous solution, so the answer is time t equals 5. So I'll just write t equals 5 seconds. Part E says to graph the function of the height h of the ball in feet to the time t in seconds. Include and label key features of the graph, such as the vertex, axis of symmetry, and t and y intercepts. Okay, so here's the summary, and it's typed out so it's more legible than my chicken scratch. And it says the graph should include identification of the intercepts, vertex, and axis of symmetry. So the vertex was 2.125 or 2 1/8, comma 132.25 or 1/4. The t-intercept for -0.75, comma 0 and 5, comma 0, and the y-intercept was 0, comma 60. And it says to see the graph of y equals h of t. So that's the next thing we do is we graph it. So unfortunately, I think a lot of the times this module tells you to graph something and then it gives you a blank piece of paper with no graph. I'm not sure if the student version and your student version has a graph, but it's always a good idea to have graph paper. If you don't have it, just Google printable graph paper and print a piece out. Okay, so here's the graph. And everything's labeled up except the x-axis should have a t here, and the y-axis was what? t time, and this is y-intercept, t axis of symmetry, and t and y-intercept. So they are calling this the y-axis. So the t-axis and the y-axis should be labeled. And here, it's over here. All right, so there we go. So we have this 0, negative 3/4, comma 0. We have this 0, 5, comma 0. We have the y-intercept of 0, comma 60. So really, if you wanted to, this would be the building right here. Okay, he's standing on the corner of the building, throws it up, and it reached 132 1/4 inches, turned and went down, and the axis of symmetry is t equals 2.125 or 2 1/8. So there's the graph. Okay. Okay, so page 4 brings us to mathematical modeling exercise 2, and it says read the following information about business applications. So pause the video and read this. Or if you have your module in front of you, read it from there. But I am not going to take the time from this video to read all of this. I will just come down here and start at A. So here we go. Okay, so assuming that you've read that, I have highlighted what we're going to use here, the formulas. So now let's answer the questions related to the following business problem. It says a theater decided to sell special event tickets at $10 per ticket. $10 per ticket to benefit a local charity. The theater can seat up to 1,000 people, and the manager of the theater expects to be able to sell all 1,000 seats for the event to maximize revenue for this event. A research company volunteered to do a survey to find out whether the price of the ticket could be increased without losing revenue. The results showed that for each dollar increase the ticket price, 20 fewer tickets would be sold. Okay, so if they charge $11, only 980 people would come. If they sold it for $12, 960, and so on. So every dollar they add to that $10 ticket, 20 less people will come because 20 of those people will find that too expensive. Okay, so that's 2%. They lose 2% of the population for every dollar increase. So A says let X represent the number of $1 price per ticket increases. And then it says write an expression to represent the expected price for each ticket. So you want to save this. Let X represent the number of $1 price per ticket increases. Okay, and then if each ticket is $10 plus a possible price increase in $1 increments, the price of the ticket will be 10 plus 1x. So if I increase this $1, 1 times 1 is 1, the price would be 11. If I increase it $2, 2 times 1 is 2, plus 10 is 12. Okay, so the initial cost plus 1 times the $1 increases. Okay. Okay, page 5 brings us to part B of this problem, and it says to use the survey results to write an expression representing the possible number of tickets sold. So what they were saying was in the prior page, since 20 fewer seats will be sold for $1 each, for each $1 increase, 20 fewer seats, then 20x will represent the number of seats fewer than 1,000 that will be sold. So then here's our equation. Okay, so the equation will be 1,000 number of seats minus 20 times x, which is the $1 increase, representing the expected number of tickets sold at this higher price. So if we add a dollar, it'd be 100 minus 20 times that dollar, or 20, which would be 980. And if I increase the price $2, that'd be 1,000 minus 2 times 20, which is 40, or 1,000 or 960, and so on. Okay. Now part C says using X as the number of $1 ticket price increases and the expression representing price per ticket, write the function capital R to represent the total revenue in terms of the number of $1 ticket price increases. So if I go back and look here, where is revenue? Right here. So it's price per unit times quantity of items sold. So, okay, so in this case, total revenue is price per ticket times number of tickets. So what we're going to do is use the capital R with respect to x. So R of x equals, and our linear function from part A, which is how much each ticket is. So it's 10 plus x, price per ticket, $10 plus any $1 increment, times number of tickets, which was this right here, 1,000 minus 20x. Okay, and so then we're going to FOIL this, if you will. So 10 times 1,000 is 10,000 for the first terms. Outer would be negative 200x. So first is 10 times 1,000, 10,000. Outer is 10 times negative 20x, or negative 200x. Inner is x times 1,000, which is plus 1,000x. And last is x times negative 20x, or negative 20x squared. Okay, so now let's just clean this up, and that is going to equal negative 20x squared. Okay, combine your two middle linear terms. That 100 or 1,000, that is a 1,000, right? Inner x times, not enough zeros here, so let me fix that. That should be 1,000x, my apologies. So now 1,000 minus 200 is a positive 800x, and then plus 1,000 as my, or 10,000 as my constant. Okay, so that is R of x. R of x equals negative 20x squared plus 800x plus 10,000. Okay, part D. How many $1 ticket price increases will produce the maximum revenue? Okay, so the maximum revenue, remember this is a quadratic, negative a. So let me just draw this little picture here. Okay, there's my parabola. And so this x-axis here would be 0 tickets sold. So there's going to be a point where it'll get so expensive that nobody's going to come. Crickets will be heard. Okay? So how many $1 ticket price increase will produce the maximum revenue? That would be right here. And keep in mind, that's just going to be another vertex problem. So what we're going to do is complete the square here. So here we go. So I write R of x equals, and the first thing you do is group your x terms. Actually, yes, group your x terms first. So I'm going to write negative 20x squared plus 800x, and then leave that 10,000 all by itself outside here. And then I'm going to factor out a 20 here, so I'm going to get R of x equals negative 20 times x squared minus 40. 20 times 40 is 800, x plus 10,000. Okay, finally we're going to find out what the completed perfect square is. So it's going to be negative 20 x. Let me change that negative 20, by the way, to a different color, like I always do, just to clarify we're multiplying. Inside, negative 20 times x is negative 20x squared, right here. So we're going to get negative 20 times x squared minus 40x, but then we're going to take half of 40, which is negative 40, which is negative 20. Negative 20 squared is 400. Okay, but notice the blue. If I distribute that, I get a negative 800. So what I've really done is subtracted 800 from this, so I need to add 800 back. So it's going to be 10,000 plus 10,000 plus 800, or plus 8,000, I mean. 20 times 400 is 8,000. Okay, so if I subtract 8,000 here, negative 20 times 400 is negative 8,000 plus 8,000, then it's still equal. Okay, so then what we need to do is just finish this and find the vertex form. So let me go back to red now. So R of x equals negative 20, perfect square of, oh, I lost my squared here, So that's going to be x minus half of our b squared. And then plus this product here, or this sum here, I'm sorry, 10,000 plus 8,000 is 18,000. Okay. That will give us, that's the vertex form. So the vertex is, remember, x minus h, so h is 20, plus k. K is 18,000. What does that mean in the context of this problem? If you increase the price $20, you decrease, or you increase the number of people in the seats $18,000. Okay, so using the factors, set the equation equal to 0 to find the zeros of the function. So what I'm going to do now is set this, let me move that. That is our vertex. This is our vertex. Alright, so I'll just put vertex. It's 20, 18,000. And I probably shouldn't use a comma there because it's confusing with the two commas. Alright, so anyhow, now we're going to set this equal to 0. And when a quadratic is set equal to 0, then we are going to use those factors and find the roots or the zeros. Okay, so what we're going to do now is we're going to go back up. Now keep in mind, here's r of x up here, and it is this right here. So if we factor this again, it's already been factored because we multiplied it to get this function, right? So these are our two factors. So if I now take r of x equals 10 plus x times 1,000 minus 20x and set that equal to 0, then x would equal negative 10 here, and x would equal divided, okay, let me just show that over here, 10,000 minus 20x equals 0. Subtract 10,000 over to the other side, I'd get negative 20x equals negative 10,000. Divide both sides by negative 20, and I get x equals positive 500 or 50. 50. 1,000 divided by 2, 10,000. Oh, it's not 10,000, it's 1,000. So I was confused there a little bit, didn't make any sense, and I always take a step back, and that should be 1,000. 1,000 minus 20x, 1,000 minus 20x, 1,000 minus 20x equals 0. Subtract 1,000 from the other side, I don't have this 0. It's 1,000 divided by 20 would cancel this 0 and this 0. Negative 100 divided by negative 2 is positive 50. Alright, so that's an extraneous solution. Negative 10 does not make sense. And so there's zeros at negative 10 and 50. The vertex will be on the axis of symmetry, which is the midpoint between negative 10 and 50. So midpoint is add the 2, divide by 2, so that'd be 40. Negative 10 plus 50 is 40 divided by 2 equals 20. So the vertex is 20. All right, so $20 increase will find the maximum number of profit. Okay, so it says how many $1 ticket prices increases will produce the maximum revenue? 20. So the answer is 20 $1 increases. 20. So I'd say, put the answer here. 20 $1 increases. Okay. E says, what is the price of the ticket that will provide the maximum revenue? Okay, so what we're going to do there is the price per ticket expression is 10 plus x for x equals 20. Okay, we have 10 plus 20 equals 30. Substituting in that 20. The price per ticket that will provide the maximum revenue is $30. And then it says, what is the maximum revenue? That's this problem up here. Okay, so according to the R value at the vertex, the maximum revenue will be right here. Our constant, $18,000. The vertex form, 20, 18,000. Maximum revenue would therefore be $18,000. Okay, page 6 brings us to part G. How many tickets will the theater sell to reach a maximum revenue? Well, the maximum revenue was $18,000, okay? And $30 per ticket, so we're going back to the last two questions, actually. So $18,000 was the maximum revenue, and the price per ticket to provide the maximum revenue was $30. So this is asking how many tickets will the theater sell to reach that maximum revenue. So you take the $18,000, and divide it by the $30, and the zeros cancel. 3 goes into 18 6 times, and then 2 more zeros, so 600 tickets. Alright, part H. How much more will a theater make for the charity by using the results of the survey to price the tickets than they would had they sold the tickets for their original $10 price? Okay, so at $10 per ticket, the theater would have brought in $10,000 after selling all 1,000 seats. So they were initially going to charge $10 per ticket, not $0. They were initially going to charge $10 per ticket, and there were 1,000 seats, which would give them 10 grand. Okay, and this says how much more? Well, $18,000. The survey price that told them to sell the tickets for $30. So they only sold 600 tickets. There were 400 empty seats, but they made $8,000 more by charging $30 instead of the $10 for a full house. Pretty interesting stuff here. So subtract that $10,000 that they made if they sold them for $10, and the answer to this question is $8,000. Okay, moving on to exercise 1. Exercise means your turn. Pause the video, see if you can do this, and then come back and check your solution. So here we go. 2 rock climbers try an experiment while scaling a steep rock face. They each carry rocks of similar size and shape up a rock face. One climbs to a point of 400 feet above the ground, and the other climbs to a place below her at 300 feet above the ground. The higher climber drops her rock, and 1 second later, the lower climber drops his. Hopefully they didn't drop it on each other. Well, he couldn't drop it on her because he was below her. Note that the climbers are not vertically positioned. Oh, so there we go. No climber is injured in this experiment. I love it. A, define the variables in this situation and write the 2 functions that can be used to model the relationship between the heights h1 and h2 of the rocks in feet after t seconds. Okay, so what we want to do is represent some variables. So what is h1? h1 is the height of who? Height of the first climber. Okay. Okay, so h1 is the height of the first climber. All right, and then h2 is the height of the second climber. Okay, and then t represents the number of seconds passed since the higher climber dropped her rock. Okay, So we need to say that. T is, how would we say this? T is the number of seconds T is the number of seconds passed since the higher climber dropped her rock. Okay, since the higher climber dropped her rock, that is T. T minus 1 represents the number of seconds the lower climber dropped his rock, because it did say 1 second later the lower climber dropped his rock. So T minus 1 is the number of seconds passed since the lower climber dropped his rock. Okay, so there's T sub T minus 1. All right, and then finally, so we have H sub 1, we have H sub 2, we have T for time, we have T minus 1 for his time, and now we finally have H sub 1 of T equals negative 16 T squared, okay? That's the physics formula. Negative 16T squared plus 400, okay, because 400 feet above the ground, and H sub 2 of T equals negative 16 T squared plus 300. So there's our two equations. Okay, page 7 brings us to part B, and it says, assuming the rocks fall to the ground without hitting anything on the way, which of the two rocks will reach the ground last? Show your work and explain how you know your answer is correct. Okay, so let's start with her, and she was H sub 1. Oops. H sub 1 of T is my function, equals negative 16T squared plus 400 from the last page. So we want to set that equal to 0. And then factor. So then negative 16 will go into 400 25 times. So negative 16 times a negative 25 equals a positive 400. So now I can factor this. I have a difference of perfect squares. The square root of T squared is T plus the square root of 25, and the square root of T squared minus the square root of 25. All right, equals 0. So this negative 16 is not going to get used. We just have to set each factor equal to 0. So T plus 5 equals 0 will give us T equals negative 5. And this one will give us T equals positive 5. Since this is an extraneous solution, we aren't going to use it. So the answer is 5 seconds. Okay. So it'll take 5 seconds for the higher climber's rock to hit the ground. Now I'm going to do the same for H sub 2. H sub 2 equals negative 16 T squared plus, okay, let me go back, 300. And set that equal to 0. Okay, so I factor out a negative 16. Let me see, no, 300, that won't work. 300, just checking real quick, divided by 16. No, it's a fraction, will not work, so let's do something differently here. So what we have to do is move the 300 over to the other side. So we're going to get negative, oops. So here's what we're working with. Negative 16t squared plus 300 equals 0. Subtract 300 from both sides, leaving us with negative 16t squared equals negative 300. Okay. Okay, I'm pausing here because I made a mistake. So now let me go back. And h of 2 is not negative 16t squared plus 300. Okay, and I apologize for this mistake. I need to fix this. There is a 1 second later that we need to take into consideration here. So it's negative 16, not t squared. It is negative 16t quantity minus 1 squared plus 300. Okay, so going back to the last page and fixing that, and now I'm going to use that equation here, and so let me fix that. So this is going to be negative 16t minus 1 quantity squared plus 300. Okay, so then I want this equal to 0. Then I want to take that negative 16 times t minus 1 quantity squared and set it equal to negative 300 because I moved that over to the other side. Okay, so now I'm going to divide by negative 16 both sides. So I get t minus 1 squared equals 300 over 16, because a negative divided by a negative is positive. So 300 over 16. Okay, so now I'm going to take the square root of both sides to get rid of this squared. So when I take the square root of this, I just simply get t minus 1, the square root of a square. And the square root of 300 I'll just leave as the square root of 300 divided by the square root of 16, which is 4. So then I'm going to add 1 to the other side. So t is going to equal 1, and that's plus or minus, by the way, when you take a square root. So it's 1 plus or minus the square root of 300 divided by 4. Okay, so let's put that in our calculator. And it's going to be 1 plus the square root of 300 divided by 4. And I'm going to put this in parentheses just in case it does the order of operations correctly. So there it is, and I hit enter, and I get 5.3 approximately. So I will say t is approximately 5.3 seconds. And then if I do the other one, simply just go second enter to bring that back and change that plus in front to minus. It's just a lot quicker that way. And I get a negative 3.33. Okay, obviously that doesn't make sense. We can't have negative time. So it took him, his rock, to drop. It took 5.3 seconds. So the lower climber's rock will hit the ground after 5.3 seconds. The higher climber's rock will hit the ground after 5 seconds. Okay. Okay, part C says to graph the two functions on the same coordinate plane and identify the key features that show that your answer to part B is correct. Explain how the graphs show that the two rocks hit the ground at different times. Okay, so I'm just going to bring a finished product in because it's so hard to draw with this pen. Okay, so here's the graph. So let me just go through this with you. This is the initial time 0. This is the higher climber's height, 400 feet. She drops her rock and it starts to fall at this rate. And it hits the ground after 5 seconds. Climber 2 is only 300 feet off the ground, but he doesn't let go of his rock until it's 1 second has passed. So she lets go of her rock, and her rock starts to fall, and it's right here. And then he lets go of his rock, and it starts to fall, and then here's the 2, and hers catches up to his height right here, just below 200 feet, which was about a little more than 3.5 seconds, 3 3/4 seconds, 3 seconds, 3.275 seconds. And then her ball or rock lands before his. Okay, page 8 brings us to exercise 2. Amazing photography studio takes school pictures and charges $20 for each class picture. Okay, so underline the information. $20 for each class picture. The company sells an average of 12 class pictures in each classroom. They would like to have a special sale that will help them sell more pictures and actually increase their revenue. They hired a business analyst to determine how to do that. The analyst determined that for every reduction of $2 in cost of the class pictures, there would be an additional 5 pictures sold per classroom. Write a function to represent the revenue for each classroom for the special sale. Okay, so we'll let X represent the number of $2 reductions in price. That's this one right here. X is the number of $2 reductions. Okay, so then the price expression would be 20 minus $2 times each reduction, which is X. The quantity expression would be then 12 plus 5X. 12 class pictures plus 5 pictures sold per classroom, 5X. So the quantity expression is 12 plus 5X. So our revenue equation is going to be R of X equals, and it's the price times the quantity, so it would equal 20 minus 2X times 12 plus 5X. So then we're going to FOIL this to get a quadratic. So 20 times 12 is 240. Outer is 20 times 5x, which is 100x. Inner is negative 2 times 12x, which is a negative 24x. And last is negative times a positive, which is negative. 2 times 5 is 10, and x times x is x squared. Combine your middle terms, and we're going to get r of x equals negative 10x squared. 100 minus 24 is a positive 76x plus 240. So to find maximum revenue, we need to find the vertex of this function, r of x. We need to put it in vertex form. So it will be r of x equals negative 10x squared, in parentheses with the 76x, plus 240. Okay, factor out 10, so that would be negative 10 times x squared plus 7.6x plus 240. Okay, so now we're going to complete the square, so that's going to equal negative 10 parentheses. Let me change the color of that. Negative 10 parentheses x squared plus 7.6. I'll just use my calculator for this. Clear. 7.6 divided by 2 is 3.8. Then you square that. You get 14.44. Or we could just do it this way, since it's a weird number. Plus, change the color, plus, it was the 3.8, half of this. So let's just do it like this, 3.8 squared, because it's a weird number. And then at the end, it's going to be plus 240. And since I'm subtracting 10 times 3.8 squared, then I want to add the 10 times 3.8 squared. So what we're going to end up with is, here, let's just put it right here, plus 3.8 squared times 10. So negative 10 times 3.8 squared and positive 3.8 squared times 10 is over here. They offset each other. All right, so then simplify this and we get negative 10x plus 3.8 quantity squared plus 240 plus 3.8 squared is 14.44 times 10 would be 144.4. So that would equal negative 10x plus 3.8 squared plus 240 plus 144 is 384.4. So my vertex is 3.8, negative 3.8, comma. Oh wait, that is minus, by the way. Right here is minus. Negative times negative is positive, so it's not negative, it's positive 3.8, comma, 384.4. There's my vertex. So that what would the special sale price be? So the studio should reduce the price by between 3 or 4, 3.8, between 3 and 4 $2 increments. If we check the revenue amount of 3 reductions in price, negative, it would be negative 20 minus 2 times 3, which is 6. Negative 20 minus 6 is 14. Okay, so let me just bring that in so you understand what I'm saying. Okay, so if we check the revenue amount of 3 reductions, the price is $20. The $20 minus the 2 times 3, which is 6, which would be $14. The quantity will be 12 plus 5 times 3, or 15. 12 plus 15 is 27 pictures per classroom, so the revenue would be $378. Now check 4 reductions. So you take 20 minus 2 times 4, which is 8, which is $12. The quantity would be 12 plus 5 times 4, or 20, which is 32 pictures per classroom, and the revenue for 4 reductions would be $384. The special sale price should be $12 since the revenue was greater than the price was when it was 14. All right. Part C says, how much more will the studio make than they would have without the sale? So the revenue for each class will be $384 during the sale. Without the sale, they would have made $20 per picture for 12 pictures, or $240. So 384 minus 240 is an increase in revenue of $144 per classroom. Okay, page 9 brings us to the end of lesson 23. Review the lesson summary and go to your problem set.